So, this is a cell phone detector circuit. It is the mini project made by group of A3 roll numbers 49, roll number 49. This circuit basically detects message sent via mobile, or detects when call is received in the mobile. That is, when a mobile sends or receives radio frequencies of the range of 0.98 gigahertz frequency, this circuit detects it and the LED glows. So when we keep a mobile in this in the range of the circuit, and when the mobile receives a call, or when mobile uh, receives a message, or when mobile sends a message, this circuit would start receiving those radio frequencies, and via those radio frequencies LED would start glowing. So this is basic cell phone detector circuit. The components used are, main component used is this CA3130 IC, and another main component used is a BC548 transistor. And there are components like two capacitors and resistors, etc. 3 capacitors and 4 resistors. So the detection work of this frequency is done via those 0.22 microfarad capacitor. So we would jump on to working. The radio frequency is captured through the 0.22 microfarad disk capacitor and then is sent to the CA3130 IC, which is an operational amplifier. Then the signal is amplified to a certain voltage and then is sent to the base of this BC548 transistor. Hence the circuit closes and current flows through the positive of the LED to the ground. Here an LED is assumed to be connected. 200 microfarad capacitors in parallel are used for detecting radio frequency signals from mobile phone. These capacitors are working as loop antenna for system. When there is a call or SMS, then capacitors in parallel detect the data transmission frequencies or radio frequency signal, and output of op-amp goes high or low, fluctuating, due to generated current at the input side of op-amp. Due to these fluctuations, LED turns on and off through NPN transistor, which starts blinking the LED. It continues until the signal transmission ceases. An ordinary radio frequency detector using tuned LC circuit is not suitable for detecting signals in the gigahertz frequency band used in mobile phones. The transmission frequency of mobile phone ranges from 0.9 to 3 gigahertz with a wavelength of 3.3 to 10 centimeter. So a circuit detecting gigahertz signal is required for mobile bug. Here the circuit uses 0.22 microfarad capacitor to capture radio frequency signals from the mobile phone. The lead length of capacitor is fixed as 18 mm with a spacing of 8 mm between the leads to get the desired frequency. Now the output of ICCA3130 is used in the circuit as a current to voltage converter from capacitor C2 between its inverting and non-inverting inputs. It's a CMOS version using gate protected P-channel MOSFET transistor in the input to provide very high input impedance. very low input current and very high speed of performance. Capacitor C2 in the junction in conjunction with the lead inductance acts as a transmission line that intercepts the signal from the mobile phone. This capacitor creates a field, stores energy, and transfers the stored energy in the form of minute current to the input of IC. This will set the balanced input of IC and convert the current into corresponding output voltage. Capacitor C1 along with high value R1 keeps the non-inverting input stable for easy swing of the output to high state. Resistor R2 provides the discharge path. Resistor R2 provides the discharge path of C1. Feedback resistor R3. This R3 makes the inverting input high when the output becomes high. Capacitor C3. Function of capacitor C3 is like a strobe. Capacitor C3 is connected to 8 pin, that is the strobe, and null input, that is pin 1 of IC, for phase compensation and gain control to optimize the frequency response. So when the cell phone detector signal is detected by C2, the output of IC becomes high and low alternatively, according to the frequency of the signal as indicated by LED. The unit will give warning indication if someone uses mobile phone within a radius of 1.5 meters only. So the circuit works only within a range of 1.5 meters. So this is the circuit diagram of that cell phone detector circuit. That's it. Thank you.